Let's start by taking a look at the definition of heat and work. As you can see here, heat and work are two different ways through which the energy manifests in a chemical reaction. So the thermodynamics deals with the relations existing between heat and work and the energy in any transformation. The main important point that makes the thermodynamic very useful in the study of the reaction is that any reaction can be described by neglecting its evolution from the reactants to the products. So, in the thermodynamics approach, we are interested in the initial and final state of a reaction without taking into account the intermediate stages through which this reaction evolves. But, due to this fact, thermodynamics has some limits. For example, it doesn't take into account the reaction velocity that is a crucial aspect of any reaction in order to understand its practical application in any process. Indeed, the reaction speed and the reaction velocity is something that really affects the process, and so we have to know it, but this argument will be a topic of the lessons to come. So now, in this lecture, we are going to focus on the thermodynamics. So, the thermodynamics is defined through two laws that are here reported. The first law of the thermodynamics, it states that the energy conservation and sets the relation between heat, work, and energy variation in a process. Moreover, it allows to deal with the thermochemistry or on theoretical basis. The second law of the thermodynamics sets the direction, the spontaneity, and the magnitude maximum performance of a reaction. Namely, we are going to see in the next class that it's very important to determine if a reaction is spontaneous or not in order to understand if it needs some energy provided from the external of the system or if it's able to produce work or heat. Moreover, the second law sets the maximum limit of work obtainable by a chemical reaction. This, again, is very important in order to understand if a process is efficient or not, and if we are able to extract a certain amount of work from a chemical reaction or any other process. So before we start talking about the reaction and talking about thermodynamics, we have to define the system. Indeed, the system is meant to be the structure on which we perform the work or through which, from which we can extract the work. So here in this slide you can see that there are three principal different kind of systems: the so-called open systems, the closed systems, and the isolated system. Both are defined on the characteristic they have to exchange a mass or energy or both while performing a process. As you can see, the system is defined as the part of microscopic universe in which the observation and the experimental measurement are carried out. So we are interested in what happened in the system. Usually, this is defined as the reaction mass. So we are a system evolving, made of a certain amount of matter, and that is our system. It's also important to define what is the environment, that of course is different from the system, and the environment is defined as the part of the universe external to the system, normally the reactor and the related equipment plus the surrounding space.